talking this morning about Flashrom, kind of the little project that could. Well, so Ron was just talking a little bit about the history of Flashrom, and actually that happens to be my first topic. So we're going to go over some history. Since I work on the Chromium branch, or fork, whatever you want to call it, I'll be comparing a little bit upstream versus Chromium, why we have two separate code bases, and go over some status, some pain points, testing strategy, and talk about the future, and maybe hopefully how Chromium and upstream can become one again, or at least much closer than they currently are. All right, so a little bit of history. So if you do svn log in the Flashrom repository, you see. Wait a second. I'm sorry. The coreboot v1 repository. You see R490, and so why was it 490 instead of R1? Well, because Flashrom was not a separate project at the time. It was actually in the util directory where we keep, most of the utilities that are associated with Flashrom, with coreboot. Except at the time it wasn't called coreboot, it was called Linux BIOS, and so back then it was Linux BIOS /util /flash and burn. Flash and burn was the name of the utility. Hey Ron, do you just want to give a quick recap of how you came up with that name?
Okay, yeah. So we had supercomputers at Los Alamos that were based on 128 processor racks of SGI R10000s with the NUMA interconnect, and a bigger machine was 48 of those. I forget how many tens of millions that was, and then we had a 16-node guy. And for testing, they had two 4-node guys, and one was called Flash and one was called Burn, because it was assumed that we were going to fry them on a regular basis. So it seemed like a good name for, since all we did back then was fry things, it seemed like a great name for the utility.
And we continue to fry things to this day. So yeah, if you want to check out the original commit and Ron's profanity-laden commits afterward.
Yeah, just look here at the R490, and the commit message is "damn it."
And the one.
I haven't checked. Let's see.
It's also.
I gotta go back and look.
So yeah, check out the coreboot v1 repository and just check it out because it's fun. Okay, so the maintainers of Flashrom were originally at Los Alamos National Lab. Ron, of course, gave us the very first commit and many thereafter. One of our engineers, Ollie Lowe, really great guy, kind of took it over. And so Ollie originally started at Silicon Integrated Systems, SIS, which is one of the first commercial chipsets that was ported, that had a coreboot port for it, done by the vendor. And Ollie came and joined Lanel, and he was maintaining Flashrom for a while, Flash and Burn rather. And then around 2006, the German invasion happened, and Stefan Reinauer got involved, Uwe got involved, and Carl Daniel got involved, and Carl Daniel took over. And then the Austrian invasion, Stefan Tauner came along around 2011, and he's the current maintainer. And of course, there's been a lot of contributors, just kind of come and go. It's a very popular project now, and there are a lot of people running it on a lot of different machines, and we occasionally get patches from just random people. And of course, there are commercial entities as well, such as Google maintains some parts of Flashrom for Chromebooks, and actually there are a lot of companies out there that maintain forks of Flashrom for their products. Actually, if you just go to Google and search GitHub for Flashrom or search other code hosting sites for Flashrom, you'll see quite a few hits. Okay, so since I'm with the ChromeOS team, I want to talk a little bit about upstream versus Chromium, the Chromium branch, and why we did it, and just a few differences between our requirements and the requirements of the general community. So, so I actually looked at the history, and wow, 2010. That seems like a long time ago. But yeah, we were coming up with the CR48, the very first Chromebook, and obviously we needed a way to iterate on our firmware development efforts and something to update firmware in the field as part of our auto update mechanism. And Flashrom seemed like a natural choice, since of course ChromeOS is based on Linux. But we had a few different priorities. So at the time, Flashrom was becoming more and more verbose. I think Carl Daniel described a wall of text that would appear on your screen whenever you ran Flashrom. It was just incredibly verbose, just tons and tons of information, and of course when you want something that doesn't spook, even developers might have kind of a hard time parsing it all. So just to make it easy for scripts to read it and present more of a stable interface, one of the first things we did was just get rid of a lot of the output, just make it much, much quieter. These days, Flashrom can output the verbose text to a file and potentially output a lot less to the console, which is very, very good. That's I think that's a feature we need to import into Chromium, so I'll get right on that. SPI flash write protection is very important to us. That's central to the ChromeOS security model. So we had to add a bunch of stuff to deal with write protection mechanisms on different chips and also embedded controllers. And unfortunately, in the earlier days, the embedded controllers we worked with were proprietary, so we couldn't necessarily develop the code that we wanted upstream. Instead, we had to have an internal repository where we could check stuff in and then build it, test it, do whatever we had to do, and then, of course, release the code before the product launched. But while we were still developing stuff, we had to work with some proprietary code. But the highlight about that is that it's changing, because now all the Chromebooks use the open source Chrome EC. So now we don't have this barrier of having to deal with proprietary embedded controller code that we have to keep secretive before the launch of the product or whatever. Also, to help with our auto update mechanism, we introduced the flash map, or fmap, into the firmware binary, which will tell us exactly which regions we can clobber or update. And we also made it device tree aware, because device trees are used pretty heavily on ARM-based systems. Another thing with Flashrom upstream, one of the problems is that it doesn't interact very well with some power management daemons. One of the main problems is that it has the self-calibrated delay loop. So whenever the code calls udelay, so whenever it calls udelay or my udelay or whatever it's called, it'll just sit there in a for loop for some amount of time, or for some amount of iterations, rather than using the system timers. And that worked pretty well back in the day, but something we've seen in recent years, especially on the ARM systems, is that that self-calibrated delay loop can get wildly out of sync just due to the very rapid frequency shifting and very aggressive DVFS of the modern systems. So, so the interactions with power management became a little more complicated in our case. And the unfortunate thing about Flashrom upstream is that you don't want to necessarily have to support every single distribution out there with the upstream Flashrom. But for Chromium, of course, ChromeOS uses a certain implementation of power management, and we work with it. In fact, our power management daemon will see if there's a file created by Flashrom, and if that file exists, then it will do things like disable shutdown, because you don't want to shut down in the middle of a firmware update. And it'll also prevent the machine from going to suspend and all that other nice stuff. So since we have a very controlled environment, we're able to get away with doing distro-specific things. Let's see, so changes to how errors are handled. So, of course, the Intel management engine brought us a world of pain in the Flashrom world. For Chromium, yes, Mr. Nuke, I'm talking to you. So for Chromium...
Don't work on that part. That's completely different team.
So for Chromium, what we do when we read a region that is blocked by the ME is we ignore the error. And we just skip and fill in the buffer that we save with all Fs or whatever. And yeah, we just kind of ignore it. Whereas with upstream, if you try to flash over a protected region, you get a transaction error. And we probably see that's probably the #1 issue we see on the mailing list when someone complains that Flashrom failed on, some new Intel-based system. Is they'll paste the output and it'll say Flashrom failed to write to offset 0, the flash descriptor, which is read-only enforced by the management engine. Or they'll try to write something and it'll try to clobber the flash descriptor region, and it'll fail. And for upstream, that's just how they handle errors. And of course, for our usage case in Chromium, we want to handle things a little bit differently. And probably the last major difference is that since ChromeOS is developed for commercial purposes at a company, we staff developers, and if code reviews need to get done, we can tell people, well, Stefan can tell people, hey, you need to go review that patch, and they'll go and do it. So we're able to get code reviewed and checked in within a matter of hours or days, whereas, well, I don't know if you tried to get anything upstreamed in Flashrom lately, but yeah. But the silver lining is that the goals of upstream and Chromium are reconverging. So after some period where we kind of split apart and went different ways, I kind of see it now as coming full circle. Or I guess if we both started from the same side and we went different ways and we wanted to go half circle and then we meet on the other side or something. Okay, moving on. So current status for upstream Flashrom. So I went over to OLO, which is now called OpenHub, and they had some pretty decent insights. Has a lot of commits over its history, made by 26 contributors. It's not bad. Actually, it has a lot more contributors, because what happens is people send a patch to the mailing list, and then someone like Carl Daniel or Stefan Taunar, man, I hope I'm pronouncing his name correctly, will commit it. We'll check it into the Subversion repository. So really, there are probably well over 100 by now who have just submitted random support for chips, or maybe a chipset, a PCH, or a FCH, or an external programmer that Carl Daniel or Stefan have been credited with submitting, which shows up in the commit log and is picked up by sites like OpenHub. Has a well-established, mature code base. As we were just discussing, the code base is almost as old as Mr. Nuke. So it's been around a long time. It has a lot of momentum, but that can be a double-edged sword, of course, because it has a lot of old code, and if you have to make a change to an internal interface and you have to touch some old code, well, you don't really know if you're going to break something. The lowlights from the OpenHub stats: low number of source code comments, and I don't know how they came up with that one, because it seems pretty well commented in my opinion. And the things that aren't commented are fairly obvious. But of course, I've spent some significant amount of time looking at Flashrom source code, so maybe that's just my opinion. According to OpenHub, it's maintained by one developer. I guess that's problematic for any project, because of course if that one developer gets hit by a bus, then that kind of leaves everyone else in a bad situation. But yeah, if you look at the subversion log, Stefan Tauner, pretty much dominates the list of recent commits. But it's not a bad thing. He's a smart guy. He does a lot of great work, but it would be nice to see some more names in there too. And decreasing year-over-year commits. So this is something I kind of noticed in chromium.org as well. I'm spending a lot less time on it because it's more about maintaining it rather than adding a lot of new features, which is actually kind of good in a way. I mean, once you get to a certain point in Flashrom, you don't need to add a whole lot of new code. It's just kind of keeping up with whatever the newest hardware is out there. Flashrom, of course, has a huge user base. I didn't even know how to start counting the number of people that use it every day, but we have a lot of new names on IRC and on the mailing list. Just every week you see new names, people you've never seen before in the community, and they're asking questions or maybe even submitting a patch. Of course, it's used in Chromebooks, so everyone who uses a Chromebook, I can't give exact numbers, of course, but as you can probably tell from the number of Chromebooks that are on the market, there are a lot of people using them. They're all using Flashrom. And the nice thing is they use it without even realizing it, because unlike certain other BIOS update mechanisms, you don't have to reboot and then wait at this ugly, nasty-looking ncurses sort of thing while your system, does God knows what. It all happens in the background because it's a user space program. But in spite of how many users it has, it still seems to have an awfully small number of active developers, people who we've seen for years. So I looked over the commit logs for the last year and a half or so, and I actually only came up with like one slide of interesting things. A lot of it, there was a lot of good cleanup and a lot of new chips and chips marked as stable or tested and that kind of thing. So that's good. That's definitely something Flashrom has to do. But overall, the large changes, they're pretty minimal. So let's see. So yeah, we finally introduced package config for cross compilations. Dataprog. A lot of people, a lot of external vendors, and even people within Google have contacted our team about Dataprog support in Flashrom. So the fact that Dataprog was able to basically open their documents to us detailing their protocol that's going to make a lot of people happy. So I'd like to work on that a little bit more once I get more time. For Chromium, I had to deal with write protect schemes on some kind of weird chips. So I had to take the original implementation, which was based on the Bonn W25Q series, and make it a little bit more generic, because there were some chips where you didn't write to a status register to do certain things. You had to actually send a whole different SPI command, a whole different opcode to the chip. Another thing that we did was programmer aliases. So one of the clumsy things about the Flashrom syntax is if you need to specify something other than the chipset that you're running on, you say flashrom-p internal, and then maybe you specify a bus or something. So this is broken in the embedded world because, well, at least for like ARM systems, especially Chromebooks, because we have both the application processor, the AP, and the embedded controller, the EC, interfacing with, they interface using SPI. So the firmware ROM is connected as a slave device to the AP over SPI, and the embedded controller is also a slave device that is connected over SPI. And both of them, Flashrom can talk to both of them. So obviously you have this ambiguity, and all of a sudden Flashrom-P internal : bus equals SPI no longer works. So I introduced this notion of programmer interfaces. So rather than having this syntax where you have to specify the bus and a device on it, you say -p host, which means your PCH or your FCH or your AP or whatever, whatever the OS is running on, or -PEC, which is your embedded controller. And we also have now -PPD, which is the power delivery chip. One of our developers found it useful to be able to pipe standard in and standard out to Flashrom, so he added that support. And another kind of big thing is Linux MTD support. So of course I sit next to the kernel team, and every time some Flashrom bug comes up, they say, oh, why don't we just use MTD? And I explained to them that MTD in the past hasn't really met a lot of the requirements that we have as far as things like being able to write protect certain parts of a NOR flash chip. It's really intended for NAND flash, but in the last year and a half or so, they've actually gotten a lot better about supporting NOR flash. And actually, we hired a guy in the ChromiumOS team. His name is Brian Norris, and he's one of the Linux MTD maintainers. So he and I have been working to make MTD a really useful backend for Flashrom, and so we'll be able to read, write, erase, and set write protect bits using MTD on the backend. And that's really targeted for the MediaTek MT8173 SoC. I hope I'm remembering that number right. Yeah, you can see all the code on chromium.org. And we're making good progress on it. So yeah, this is just another way where we'll be able to have Flashrom as the command line kind of like the command line interface that the user deals with. But then Linux MTD will be able to handle all the SPI stuff behind the scenes, which is great because, of course, if you have a Linux driver doing it, then Linux internally can deal with all the complexities of DVFS and power management and making sure that things happen on time. So there's a lot of pending work as well. So before I was talking about stuff that's actually been checked in, not just stuff that's sitting up there on the mailing list or patchwork and bit rotting. There was a Summer of Code student named Lucas, and he improved on libFlashrom. libFlashrom was kind of an ongoing effort. I think Uwe started it many years ago, but there wasn't quite enough interest in seeing it through to completion. But Lucas, he made libFlashrom work, and he built a GUI on top of it. So that might help our user base expand even more, and might make Flashrom even easier to use, especially when it comes to things like layout files. Some people ask, oh, why can't I write to the full flash chip, and we tell them, oh, why don't you create a layout file? But that's, to us it's pretty simple, but to a user it's just one more kind of complicated thing to learn. So if we can make it easy to do that in a GUI, I think it'll help a lot. There's a lot of Dataprobe changes. As I mentioned earlier, Dataprobe was really cool, and they pretty much opened their documentation to us for the SF series of programmers. So, and it's a fairly popular programmer. It's fast, which sets it apart from a lot of other USB programmers. So we should really try to get that working really nicely. And then I can promise you we'll have more silicon vendors interested in using Flashrom after that. And there are a couple of interesting requests that I saw on the mailing list that just haven't really, nobody's really taken action on them. One of them is for to improve bus pirate 4 support by allowing the user to set open drain and maybe even set pull resistors in the command line. Seems like it would be pretty easy to do. It's just nobody's done it. Oh, cool. Urja's here. In fact, I was just going to talk about one of his suggestions, which is if you look on the mailing list, serial programmer future, 32-bit addressing, and Urja would like to get rid of write and pull sequences for each byte. And I couldn't agree with him more.
Thank God.
So 32-bit addressing, it will be pretty useful in the future. I know there are actually some ChromeOS platforms out there that use 32-bit SPI flash parts, but we pretend that they're 16 megabytes. I don't know. Actually, I know the reason they chose 32 megabytes is because the SoC vendor that we were working with had qualified only like 5 specific parts to work with their SoC, and they were all 32 megs or bigger, and so we just went with it. They were used to using a much more bloated firmware, and coreboot, of course, was a small fraction of what they were used to, so we didn't need to use the full 32 megs. That's Mr. Nuke laughing in the background.
What about?
Loaded firmware.
And, you know, Ron's probably chuckling too about bloated firmware. So anyway, back on topic here. Another interesting request was to make Flashrom use a lot less CPU time. So the ChromeOS profiling team, who I guess they're with the toolchain team, they profile all the code that runs on Chromebooks, and they found that Flashrom, because of that self-calibrated delay loop, takes an awful lot of CPU time, like hugely disproportional compared to other binaries in the system. And it's kind of superficial, but it would still be nice to use that as sort of an impetus to moving towards trusting the operating system's timers a little bit more, just because we sort of need to do that with the new like frequency scaling schemes out there that are totally screwing up the self-calibrated delay loop. Some general pain points of Flashrom. One thing I noticed is a lot of emails we get on the mailing list is people saying, hey, my chipset works, or my flash chip works, or I tested with this particular laptop from HP or Dell or whatever. And then maybe sometime in the future it'll be marked as working on the wiki. But that's all very manual. And so I'm wondering if there's a way we can automate this a little better. With coreboot, our answer to not having to update a testing matrix of motherboards was board status, which not only gives us that little check in the matrix, but it also gives us a lot more useful details. So, I mean, we can include a verbose log of Flashrom running on the thing and have all the have the full descriptor table dumped and have all kinds of useful information included rather than just does it work or not. Another pain point is the source code management. We've gone over this on the mailing list. I don't want to get into holy wars, but it does say something when the guy who OpenHub thinks maintains the project uses GitHub rather than the actual source code repository that Flashrom is hosted in. Reviews, totally understandable. You know, it's an open source project and it's powered by mostly volunteer effort, and everyone's swamped with their own things that they have to do for work or their personal life. So it just takes a long time to get things reviewed. We probably should look into modernizing the review process, again referring to the mailing lists, the proposed changes to the Flashrom hosting and workflow thread. just because I don't know about other people, but for me, downloading a patch and then patching it in and then running it and then seeing stuff break and then trying to send inline comments on the mailing list is a lot less efficient than signing into, say, the coreboot Garrett interface and then seeing the diff online and then just commenting right then and there. But this is something where people who are actively maintaining the project get to call the shots, and so whatever works for them. But I would encourage them to be a little bit flexible. Testing. So testing in Flashrom for upstream seems to be pretty much manual. And the test script in the util directory hasn't really seen any significant changes since 2010. That's when I first uploaded it for testing the BIOS ROM on very, very early Chromebooks. So, and part of that's my fault. I haven't really been active in maintaining that, but that's something that we should definitely do and hopefully tie into more of our processes, especially on the ChromiumOS side, where we have our test team and we have auto test running frequently on these machines. Two of the things that make it difficult to test Flashrom, especially on laptops, is the embedded controller, but also things like the management engine and the AMD IMC, just because they tend to bang on the SPI-ROM at the same time Flashrom wants to. So yeah, so you really have to be on a supported platform in order to test. And if you're on a supported platform, odds are it's not going to have the exact chip that you want to test. So, so our testing capabilities rely on Flashrom being able to access the SPI-ROM freely without intervention from other MCUs or embedded controllers or whatever. And well, yeah, mostly that. You need to be able to access the SPI-ROM reliably without interference. And one thing that we can do if we migrate to more of a coreboot-like workflow is incorporate Jenkins and have build testing. I'm not an expert with Jenkins, but hopefully we could also test builds with Clang and maybe even cross-compilation with, so we can compile it in DOS. Or Windows or whatever other environments people are using Flashrom in. So those are all some specific details, but when I was writing up that slide, I was also thinking of some of the bigger problems. So Flashrom is, as I mentioned earlier, it's a pretty popular project, but in a way it's kind of a victim of its own success because it's run by so many different people on so many different platforms and so many different operating systems that testing everything is basically impossible, or at least unfeasible for open source projects. An open source project that's not Linux, where there's tons and tons of commercial developers banging on it. So, so every time someone like Stefan does a huge cleanup and improves the code quality, unfortunately, he can't necessarily test it on real hardware. And the last point here, the few active developers, they're busy, of course, and it'd be really nice if more people who use Flashrom and who appreciate it and get a lot of use out of it and who enjoy this kind of thing would step up and help maintain it. All right, so talking about the future. So Chromium's near-term goals, I'm hoping to take some of these on for the next quarter and the next 2 quarters or whatever, depending what my workload looks like, is finish up with the DataProg improvements. I think we're pretty close to having it working very well, and this includes rebasing Nico Huber's earlier patches to improve USB support. I already switched DataProg to using USB 1.0 in Chromium.org, The change hasn't been committed yet, but it's up there on Garrett, and people can download the whole patch set, which is another nice thing about Garrett, rather than having to hunt down a lot of individual patches. I want to update that testing script and maybe make a couple of testing scripts. For Chromebooks, we can use the flash map to help us with our testing, to tell us, where we can clobber the content of the ROM and what's off limits. But we'll need a way to achieve a similar effect with other systems. So maybe we'll get that through the flash descriptor, or maybe if it doesn't have a flash descriptor or an fmap, we can error out and tell the user that they need to make a layout file or something. So write protection, over the past couple of years, I've learned a few things dealing with these kind of strange chips that we use, and hopefully I can make that more robust, unify it so that we only have one write protect scheme rather than two, because right now we have the old one based off the Bonn chips and the new one that's more generic. And of course, tidy up some code and try to push it upstream. So the first targets would be the Linux NTD support, because I think that's going to be useful for a lot of people. ChromeOS support, because a lot of people, especially on the coreboot for Chromebooks community that John Lewis hosts, they'll want to modify coreboot on their systems, and they'll install whatever Flashrom comes with their distro. And I guess they don't really need the ChromeOS support for that so much, but it would be nice if they can still compile the ChromeOS code base, because it's open source and they can do that, and do some cool stuff with it. Programmer aliases, I think this would be useful for the general use case. So ordinary, Joe Schmo can say flashrom-p host, rather than trying to figure out flashrom-p, is it internal, or is it bus pirate, or is it syrup, who knows. And also the write protection stuff, of course, once I make that more robust. Flashrom's makefile, Carl Daniel made a lot of good improvements to that upstream that I need to bring back into the ChromeOS repository, Chromium repository. And hopefully we can simplify it and make it easier to include stuff that you want and take out stuff that you don't want. Part of the motivation for that is Linux's bootloader, so people can make a nice embedded environment with Flashrom in it that includes only support for the stuff that they care about. It doesn't necessarily have to support hundreds of flash chips or every single internal interface that we support. So upstream, I'm not really the upstream maintainer, but if Stefan and Carl Daniel want to chime in, or Urja even, they're certainly welcome to do so. So these are only suggestions. So, of course, I'm a fan of Coreboot's workflow. There's some friction about this on the mailing list. External programmers seem to be rather popular. A lot of people on IRC seem to be asking about external programmers. So, it'd be nice if we could improve the live USB usage, and also maybe consider some other ideas that have been submitted. So I hope to look more closely into this, along with the DetaProg improvements. And as I mentioned earlier, getting some more people to help maintain Flashrom is probably a good idea, because the current maintainers, we're all very busy, and it takes a long time to get anything reviewed these days. So it would be nice to see some more progress. All right, and so that's it as far as my Flashrom presentation goes. So let's see. So any questions, or does anyone else have any rants or raves about Flashrom?
Yes. So
yes, Mr. Nuke.
DetaProg, how are you dealing with the write speed, the actual, because you send a command and then you want to see if it wrote correctly, and you send a read, and there's like a high latency in between, and it takes like 15 minutes to flash one chip. So how do you deal with that?
Yes, it's pretty ridiculous. So, so first off, switch to libUSB 1. That's one of Nico Huber's old patches. And then after you do that, you switch to use libUSB asynchronous transfers, which is another one of Nico Huber's patches. It's been on patchwork for like 4 years or something, so we really got to get that one in at some point. Third is, for dhendraprobe, probably the thing to do is just write the whole thing and then verify it at the very end. So rather than verifying chunk by chunk, you try to minimize USB traffic and fill up the dhendraprobe buffer and blast all the bits out there as fast as you can, and then read them all at the end. So
Cool.
yeah, and you can really tell in the Flashrom source code that it was kind of designed for internal, what we call internal programmers, your PCH or your FCH or whatever. And it does a lot of these transactions in little tiny chunks. But when you start looking at external programmers, it makes a lot more sense to do them in very large chunks. So with the internal programmers, since there's very low latency on things like the SPI bus, it makes sense to write 64 bytes at a time or a couple hundred bytes at a time or whatever your SoC or PCH supports. And then if you fail, you find the failure and you quit early. And maybe you can still boot your system. When you're dealing with an external programmer, it doesn't make a whole lot of sense to do that. So you may as well just do it all at once, like do a whole lot of writes and then, do one large bulk write and then try to read as much as you can in one USB transaction. All right.
I have a question. This is Amin from Bonn. Hope you hear me good.
Yeah,
I wanted just to let you please give us an update on the EMI topic on the Intel architecture. To be true, I did not check the latest things on Flashrom the last 1 or 2 years on this topic, but what's the current status? If we want to flash a whole BIOS plus EMI SPI flash, does Flashrom use the HECI interface to communicate with the EMI? Basically, are we able to flash the EMI region?
So, I don't think we support the EMI, what is it, the MEBX, the MEBX interface in Flashrom, unfortunately. There might be something in Linux. I vaguely remember seeing something in Linux about this, and maybe you can tell the EMI to stop, or at least not sit there hammering on the SPI flash.
Mm-hmm.
But I don't think we have support for that in Flashrom yet. So going back to how we do it in Chromium, the way we've done it since the Sandy Bridge days when these EMIs started showing up in laptop chipsets, basically we would just skip over the EMI regions which are marked as read-only or totally blocked off. So the region that the management engine likes to hammer on is its own region, the EMI region, and that's protected from both reads and writes by the EMI. So for us, we attempt to read or write to that region, we see the transaction error, and we just ignore it and then move on. And from there, we can flash whatever other parts of the system we need to flash. So if the flash descriptor marks the EMI region as locked, then we skip it. If it's unlocked, well, hopefully you know what you're doing and you have a way to recover.
Right.
Yeah, because yeah, it's worked for us in the past, but I think it's mostly just luck. Like when I'm developing on a x86 platform and I have the flash descriptor unlocked, then it's mostly just by luck that it works.
Sure. All right. Thank you. I have another question. I work a lot on the Intel different server platforms, and as you know, Intel is an Ethernet NIC manufacturer, and basically, I don't know if it will be more and more into the future, but in the BIOS SPI flash attached to the PCH, I think we find more and more other firmware than the ME or the BIOS, right? So you might find the Ethernet controller firmware, which was previously on an EEPROM or whatever other component. So is there any support or planned support for basically reflashing the Ethernet controller firmware, which is in the BIOS flash independently from the BIOS? You know, so there is a region, let's say, for this Ethernet controller. Is there any support just to reflash the Ethernet controller region?
Yeah, so I think you kind of mentioned two things. One is the Ethernet, the gigabit Ethernet region, which is defined in the Intel flash descriptor specification. And well, to flash that, you just do as you would to update your BIOS. You just tell Flashrom which region you want to write to, and then it does it. I don't think the gigabit Ethernet region is write protected by default. And I think you also mentioned, I believe upstream Flashrom can also write to the option ROM on these Ethernet devices. But maybe Carl Daniel or Urja or someone else on the chat can talk about that a little more, because I haven't done it, but I have seen Intel Ethernet support in Flashrom. So we can catch up offline as well.
Sure. So I know you support flashing the standalone, let's say, EEPROM firmware when it's on a separate chip, but I'm wondering how it works, if it is working when everything is in different regions in the same BIOS flash.
Yeah, that should just work. Maybe I don't understand the question, but yeah, if everything's in the same BIOS flash, then you just upgrade your gigabit Ethernet region the same way you would your BIOS region or your flash descriptor region if it's unlocked. So yeah, let's follow up on the email list, and hopefully we'll shed some more light on this subject.
All right.
May I chime in on the issue of the write speed, for example, with dhendrix? The issue here is that Flashrom tries to update as little of the flash as possible. The strategy is essentially to pick the smallest blocks you can actually update, and then move on to even larger blocks until you find a non-failing version. And to change the behavior to just do a bulk erase all the time, and then do quick writes and from bulk verify afterwards. The easiest way to achieve that is to change the condition of a single for loop in Flashrom to actually pick the biggest chunk first. You get a bulk erase, and you get a pretty fast throughput on dhendrix and others. But yeah, that's not well, there are patches, yes, bitrot patches. But that would seem to be a very good idea to have it actually configurable or working, or even preferred thing on dhendrix. Because if a dhendrix patch is probably fast.
Yeah, so Carl Daniel, I actually had an idea about that earlier this year maybe maybe we could have some global variable. I mean, God knows there are plenty of them in Flashrom. If internal programmer is selected, then it does as you described, where it tries to only update the smallest chunk possible. So it'll use the 4 kilobyte erase, and it'll update in those little chunks. But for the default case, it should probably try to use like 64 kilobyte chunks, or maybe try chip erase first.
I'd like an option, because I mean it's very fast if you're only updating little pieces. You know, when you have to update a lot of stuff, yeah, you'd want to do the chip erase at that point. But I use it constantly, and as long as you're just making small changes, it's much better than the commercial DediProg software that I think does a chip erase every time.
Ah. Okay, so it's a little bit more complicated than I suggested.
Just to add an option, I think that would be the best solution, and let the user decide.
There's also another thing you brought up regarding the problem of trusting the timers. Back then, we didn't have any good timers available, so the delay loop was the best thing we could do, especially considering that sometimes having a millisecond delay is already too long and makes some older chips fail. And we needed delays with precision of roughly 100 microseconds. And that was the biggest issue. We didn't use mSleep, especially because mSleep also says the delay may be longer than what you want. So that was a pretty contentious issue. I gather that nowadays the timing of the operating system is better, and you can also use some busy sleep or whatever, where you get some guarantees that it won't take a lot longer than what you specified. So getting rid of that busy loop, which is even a negative thing to have, the busy loop on modern chipsets, is something we are very open to. We haven't yet seen an implementation which actually is that precise. It's mostly trying to tell the Linux scheduler to do something useful, and the scheduler does something which is sometimes useful. So if you have any code or any ideas how to do it a way which doesn't explode spectacularly, I'm all ears, and I would be very glad to merge that stuff.
So I do have a way that we do it in the Chromium repository. It's a little bit ugly, though. So as you mentioned, the reason why the delay loop is useful is because you don't really have a guarantee of when the operating system is going to finally give you some time after you call nano sleep or usleep or whatever. So you might sleep for 25 milliseconds, but then you find that it comes back after 50 milliseconds. And of course, since Flashrom is oftentimes used for the internal programmer, and it's doing thousands and thousands of these transactions, 50 milliseconds here and 50 milliseconds there certainly adds up. So the solution that is employed on some chipsets, I believe in ChromiumOS we only use the OS timers for ARM platforms. For Intel platforms, we have kind of a hybrid approach. For what we consider a short transaction, so something like setting the write protect bits, we trust the OS timer because we don't need to do a lot of these transactions. But for reads and writes, we still use the busy loop just because we're so terrified of that overhead. So it's kind of nasty, but maybe in the future we'll finally be able to switch entirely over to trusting the OS timers. But as you point out, the overhead coming back from usleep is still quite high on some platforms.
The interesting other question would be to check whether you can use tell the operating system to keep the CPU at a constant frequency for some time, regardless of whether it's low or high or whatever, but keep it constant. So you have the short delays in a precise way, and the long stuff can use the sleep stuff, the sleep commands. But that's implementation details. Probably nobody else is interested in that. Sorry about that.
Yeah, maybe the gross hack is to echo power save or performance into the scaling governor. So actually, that's one of the advantages to using Linux SPI as your interface or MTD as your interface, is because when you offload the very low-level stuff, as far as okay, well, you need to issue this command, and then you need to wait so many hundreds of microseconds to start sending your data or whatever. When you get to that granularity, it's very useful to be able to offload that work into the kernel, because the kernel, of course, can make certain guarantees that we can't in user space. So for the ARM platforms, where we trust the OS timers, it's actually worked out pretty well. I could come up with some benchmarks, and typically they come out roughly even if we use only the busy loop versus using the OS timers. And of course, with the busy loop, when I benchmark them, I try to make sure that the system's not going to sleep or doing anything crazy in the background. So yeah, offloading the very low-level stuff where timing constraints are critical, offloading that into the kernel helps a lot. And then Flashrom becomes more just focused on having a nice scriptable command interface. Okay, I guess that's it. So thank you very much.
Any controversy over to Git and Garrett?
Oh. Well, look to your left.
Yeah.
And then look at me, and then look a little bit more to your left. So there is some controversy. I mean, some people just don't really like Git too much. The thing about Flashrom is that typically your patches are kind of small and focused, like, oh, I need to add a chip, or I need to add one or two things.
But I mean, we've been talking about how much is out there bit rotting right now, and
yes,
that's one of the positive aspects of Garrett. So
yeah,
I mean,
yeah, definitely.
If we could use Garrett with SVN, I'm fine with that. But I mean, I feel like the current system isn't working.
It certainly does not for long patch sets. So
keep this angle right now. Like, this is like the perfect comparison. You have Git on the right side of the screen and SVN on the left side of the screen.
I need a drink.
Yeah, just look at the difference.
I'm actually also in favor of switching to Git.
Woohoo!
Well, there was some discussion, and there are two things I really dislike about Git. The one thing is not really being able to carry around pending and unfinished stuff easily. That's just a headache, and everybody who tried to show me that stuff essentially gave up and said, okay, well, but I still want to adapt in certain ways.
I'm totally shocked. I just want to say I'm totally shocked, and then I'm going to go to bed.
All right, good night, Ron.
Right, Ron.
Good night.
See you, Carl. Dan. See you, everyone.
Yeah.
Have a good time at the bunker.
Yeah, thanks. And the other thing is that the way to have a persistent, monotonically increasing numbers for commit numbers with Git is many people claim they're there, but essentially it boils down to apparently to tagging every commit with an increasing number.
No.
The biggest problem is that once people start merging, the numbers relative is just, some people say it's just a counter increasing from the last tag commit, and so meaning of numbers can change, but apparently Patrick has a way around that which nobody ever mentioned until right now. So the implementations I saw so far were just falling very short of the expectations. But considering that we want to move infrastructure away from subversion, I'm very much in favor of having a system which doesn't need that much maintenance anymore. So if we can get this working with monotonically increasing commit numbers, which are actually stable and are not just some hashes, I'm very much in favor of moving.
Remind me, why do we need these numbers?
But we'll discuss it offline.
Yeah.
So yeah, this will help a bit. David, you mentioned that there is no automated build testing for Flashrom. This is somewhat correct, but we do have a build bot which actually builds Flashrom for pretty much every architecture we support, including MS-DOS. The problem is just that it needs to be triggered manually, so it's not an automated build bot. And there, Garrett might provide benefits. Garrett has some other downsides. I'm funnily not the only person who is a bit wary of the way you have to use it. But the Git decision is pretty much done. So I see some progress there. I think Stefan Tauner and I had an agreement, and then the discussion died out because we were both busy again, which is not unheard of. Yeah, but I think moving to some newer infrastructure might actually help a bit.
I think you'd get a lot more reviews. Right, I know that getting stuff reviewed has been a big issue. So
yeah, the biggest problem is that on the Flashrom mailing list, nobody dares review anything except Stefan Tauner and me, because everybody thinks, well, if we don't review that stuff, it's probably too hard and nobody else dares. And then there's the stuff where
it's just such a pain to review on the mailing list.
It's not just such a pain, but the infrastructure changes are really sometimes need multiple hours of review because there's so many things and assumptions about old chips which break if you try to do it actually in a clean manner. And I'm probably the only one left with the arcane knowledge, and that's also why Stefan doesn't dare touch some parts of the code. There's room for improvement, a lot of room for improvement, and it would also help to have more people at least try to review some stuff. So moving to another review platform might be useful, but I'm deferring to Stefan Tauner on that because he's more active than I am nowadays.
So
we can take it offline at this point, I think.
Yeah.
I just wanted to check on that, and I think it would be really good. So.
One other reminder, one completely not Flashrom related thing. Vladimir just managed to do an automatic port of coreboot to the MacBook Air, and he said he wanted to talk about it for a few minutes, if that's okay with you.
all right, hey, let me stop the recording and then I'll start it again for Vladimir.
Okay, thank you.
All right, so any more Flashrom questions before I stop the recording?
I have one short question. This is Amin again. It's just for fun. Does anyone have any experience on using Flashrom on a virtualized Linux? So let's say you're using a VMware hypervisor running Linux's virtual machines, and still you want to flash the real system BIOS. Do you have any experience with this in this configuration?
VMware would be pretty poor if it allowed that.
Well, let's just say that if this actually worked, it would be a great way to break out of the virtual machine and break into the hypervisor. So if the hypervisor really actually allowed that, it would be a piece of crap. Sorry for the wording. You could probably do some memory range pass-through and PCI device pass-through to achieve something like that. It might even be usable. What certainly works is doing a USB device pass-through for external programmers to a virtual machine and running Flashrom with those. But really flashing the main system BIOS from inside a VM, it might be possible to rig something up, but certainly not with VirtualBox and certainly not with VMware. You might be able to invest a few weeks into hacking KVM to actually support what you want, but the result is likely to be unpredictable, especially because PCI transactions might get screwed up. So I would recommend against it if you have a strong use case for it. Probably it would be easier to have Flashrom running on the hypervisor directly and just provide a remote controllable interface from Flashrom, for example, the stuff which the Chromium branch should eventually get or already has. I didn't really understand it correctly with reading the image from standard in. That might be something which you can pass through to a VM, but direct flashing through the hypervisor, no, just no, please don't.
Yeah. We tried it, and it's of course extremely complicated or almost impossible.
Yeah. So it's probably really a lot easier to try to get to port Flashrom to run directly as part of a binary being part of the hypervisor. Some people even ported Flashrom to VxWorks and integrated into their operating systems there. So porting is probably quicker than doing a pass-through.
Yeah. Thank you.
You're welcome.